Hello students, so today we will discuss the laser. So in previous lecture we have studied that laser is basically the light amplification by stimulated emission of radiation. So today we will discuss the main components of a laser. We will discuss the components from which the laser is made. So today's topic is main components of a laser. Main components of a laser. So basically a laser has mainly three components. First is active medium. Second is pump. And third one is resonator. So we will discuss them one by one. So first of all, we will discuss about active medium. So what is active medium? In case of laser, any medium is said to be active medium if it is capable of decaying radiatively from its higher energy level to lower energy level, such that the energy of the emitted radiation lies in the visible region. So what is active medium? Any material which is capable of decaying radiatively from its higher energy level to lower energy level such that the energy of emitted radiation lies in the visible region. So in case of an active medium, whenever an atom is in its excited level, this is the excited level whose energy is E1 and this is the ground level whose energy is E0. Now whenever the atom de-excite from its higher energy level to ground level, then the energy which it emitted, that energy E1 minus E0 must lies in the visible region. Means this energy must be in the form of light energy. Then we said that this medium is the active medium. Now we will draw a basic diagram of laser. This is our active medium. Now we will discuss the second component of laser, which is pump. So what is pump? Pump is defined as that device which is used to excite the atoms from their ground level to the excited level. Or we can say that pump is that device which is used to attain the condition of population inversion. So pump is a device which is used to attain the condition of population inversion. So basically, what is population inversion? So students, as we have already knows that in normal situations, number of atoms in the ground level are always greater than the number of atoms in the excited level. So in normal conditions, N1 is always greater than N2. But if by some means or by using some instrument we reverse this condition and we get N2 greater than N1, or we can say that if we use some device by using which number of atoms in excited level becomes greater than the number of atoms in ground level, then we said that we have achieved the condition of population inversion. So population inversion is that condition in which number of atoms in the excited level are greater than the number of atoms in ground level. Now, let these are the number of atoms which are in the ground level. And what is the work of pump? So pump gives energy to the atoms in ground level. By using that energy, atoms get into the excited level, so that we achieve this condition which is called population inversion. So in this diagram, this is our population inversion. This is our pump. So pump transfer energy to the active medium, so that this energy is absorbed by the atoms of the active medium and these atoms get into the excited state. Now, the third component of laser is resonator. So what is the function of resonator? So resonator is a device which is used to guide the light rays in a particular direction. So when we have attained the condition of population inversion, and when atoms de-excite stimulatedly from their higher level to ground level, then light rays, or we can say that photons, are produced. So the function of resonators are to guide these photons in particular directions. So resonator gives a proper direction to the light photons produced during the stimulated emission of radiation. There are a lot of examples of resonator, and here we will discuss one such example, which is optical resonator. So in this topic we will discuss the example of optical resonator. So what is optical resonator? The optical resonator is a setup of two mirrors. It is a setup of two mirrors, mirror M1 and mirror M2. So an optical resonator consists of two mirrors, mirror M1 and mirror M2. The mirror M1 is 100% reflective, which means that it reflects all the light which strikes from it. And the mirror M2 is partially transmitting and partially reflecting, so that it partially transmits the light, falls on it. So how it works? Like this is the central axis of the laser. Now whenever the photons are produced due to the stimulated emission from the active medium, these photons are produced in random directions. Like this is a photon which is produced in a random direction. Now first this photon strikes on this mirror and this mirror reflects it. So it again goes to the mirror M1. So in this way the photons moves to and fro in these two mirrors, mirror M1 and mirror M2. and then due to repeated number of reflections at a certain time, these photons starts going parallel to the principal axis of the laser, and then this mirror allows them to pass through it, and we get a beam of photons guided in a proper direction. So we get a laser beam. So this is the basic diagram of a laser. So now we will discuss the first laser in the world, which was ruby laser. So ruby laser was world's first laser, and it was discovered in 1960 by T.H. Lehman. So ruby laser was the world's first laser, which was discovered in 1960 by T.H. Lehman. And ruby laser was also named as world's first solid state laser. It is called world's first solid state laser because in case of ruby laser, the active medium is a solid, which is ruby rod. So now we will discuss in detail about the ruby laser. So as we have already discussed that in a simple laser there are three main components: active medium, pump and resonator. So in case of ruby laser, what is active medium? In case of ruby laser, the active medium is ruby rod itself. The ruby rod acts as the active medium in case of a ruby laser. So now the question arises, what is ruby? So ruby is basically Al2O3, means aluminium oxide. When we replace some aluminium ions of Al2O3 by chromium ions, then we get the ruby crystal. So ruby crystal is obtained by simply replacing some aluminium ions of Al2O3, aluminium oxide, by using chromium ions, and we get the ruby laser. We get the ruby crystal. The ruby crystal is of pink color, and its pink color is due to the presence of these chromium ions. Higher the concentration of chromium ions, more pink color it will have. So in case of ruby laser, the ruby rod which we have used has a length of nearly 2 cm to 30 cm, and this rod has a diameter of 0.5 cm to 2 cm, and the rod is in a cylindrical shape like this. This is our ruby rod, which is taken in a cylindrical shape, whose length is in between 2 cm to 30 cm, and its diameter is in between 0.5 cm to 2 cm. So this is the first component of ruby laser, which is ruby rod. So now we will discuss the second component, which is pump. So what is pump? As I have already told you, that pump is a device which is used to attain the condition of population inversion. So in case of ruby laser, we use xenon flash lamp. Xenon flash lamp. The xenon flash lamp is used as a pump in case of ruby laser. The xenon flash lamp imparts radiations, imparts energy to the ruby rod so that the chromium ions present in ruby rod gets into the excited state. And when they de-excite from their excited state, we get the stimulated emission of radiation, or we can say that we simply get the laser lamp. And this xenon flash lamp which we used is in the shape of canonical. It is in the canonical shape, like this. The flash lamp which we used is in this shape. Like this. So in case of ruby laser, the xenon flash lamp is used. And this flash lamp is in the shape of, and this flash lamp is in the canonical shape. The ruby rod is just placed inside the xenon flash lamp like this. So the ruby rod is placed inside the xenon flash lamp like this, and this is the input given to the flash lamp. This is a capacitor and this is our output. The capacitor is used so that a high output voltage pulse can be given to the flash lamp so that it can produce a large amount of energy. Now, so till now we have discussed about the active medium in case of ruby laser, which is ruby rod, and also we have discussed about the pump. The pump is the xenon flash lamp, and now we will discuss the third and most important part of the ruby laser, which is the resonator. So in case of ruby laser, the resonator which we used is optical resonator. The optical resonator is made by simply polishing the ends of the laser rod by silver. At one end, the one end is 100% silvery coated. At one end of the ruby rod, there is the 100% silver coating, and the other end is partially silver coated. So these two ends of the ruby rod act as the optical resonator. This is the 100% reflecting mirror, and this is the partially transmitting and partially reflecting mirrors. And the photons which we have, which are produced due to the stimulated emission in case of ruby rod, they are traveling to and fro in between these two mirrors. And when they get a proper direction, then they are transferred out from the second mirror like this, and we get a laser beam which is highly directional. So this is the basic structure of a ruby laser. Clear? So now we will discuss the energy level diagram of the ruby laser. The ruby laser is a 3-level laser, and its energy level is like this. The transitions which we get in case of a ruby laser are purely due to the transition of chromium ion. So we will draw only the energy level diagram of chromium. So in case of chromium ions, let this is our ground level whose energy is E1. Now when the energy, or we can say that the light radiations are bombarded by the xenon flash lamp on the ruby rod, then these chromium ions absorb these radiations and gets to the excited state. The chromium ions which absorb the radiations of wavelength 6600 angstrom get to the excited state, say E3, and the chromium ions which absorb the wavelength of light 4000 angstrom goes to the next higher state, that this is E4. Now these two higher states E3 and E4 are least stable. Their lifetime is very small. Their lifetime is nearly 10 raised to power minus 9 seconds. Its lifetime is also nearly 10 raised to power minus 9 seconds. So these two states are very least stable. Now in these two higher energy states, chromium ions lose some part of their energy and de-excite to a metastable state whose energy is say E2, and they de-excite to this state whose energy is E2, and this is a metastable state because its lifetime is nearly 10 raised to power minus 3 seconds. Now since the lifetime of this energy level is nearly 10 raised to power minus 3 seconds, so it is a metastable level. So due to the pumping, chromium ions starts getting accumulated in this level E2, and we get the condition of population inversion. And then due to the achieveness of population inversion condition, when the chromium ions number of ions in E2 level becomes greater than the number of ions in the ground level, we get the stimulated emission of radiation, and the chromium ions from level E2 de-excited to the ground level E1 by using the stimulated emission of radiation, and we get a wavelength of 6943 angstrom, which is the wavelength of red color. So we get a red light from a ruby laser. So this is the energy level diagram of ruby laser. I will explain again. So in case of ruby laser, only the chromium ions are the active species. The laser transitions which we get are only due to the chromium ions. So this is the energy level diagram of chromium ions. In case of chromium ions, that this is our ground level. So due to pumping, from pump, chromium ions absorb the energy and get to the excited state. The ions which absorb the energy or which absorb the photon of wavelength 6600 angstrom gets to the excited state E3, and the chromium ions which absorb the photons of wavelength 4000 angstrom gets to the higher state E4. And these two higher states are least stable. Their lifetime is very small. Their lifetime is nearly 10 to the minus 9 seconds. So they immediately de-excite to the next metastable level E2. The level E2 has its lifetime nearly 10 to the minus 3 seconds or 10 to the minus 5 seconds. So this is a metastable level. So due to pumping, the number of atoms in the metastable level E2 goes on increasing, and at any instant we get the condition of population inversion, and then the atoms, the chromium ions from this metastable level E2 decay to the ground level by using the stimulated emission, and we get the photons of wavelength 6943 angstrom. So this is all about the Ruby laser. Now the output of Ruby laser. The Ruby laser has a very high output, and its output is nearly 10 to the power 4 to 10 to the power 6 watt. Now applications. So due to the high output of Ruby laser, it has a lot of applications, such that Ruby laser is used in cutting, welding, etc. So it is used in a number of ways. It is used for welding metals, it is used for cutting the metals and other processes due to its high intensity. So now there are also some disadvantages of Ruby laser. The Ruby laser has mainly 3 disadvantages. The first disadvantage of Ruby laser is spiking. So what is spiking? So when we draw a graph between the time and laser output, then we get the following graph, and this is called spiking in laser. So what is spiking? When we draw a graph between the output, laser output, and the time, we get the following graph, and this graph tells us that as the time goes, the number of stimulated emission increases. Therefore, the intensity or the output intensity of laser also increases. At certain time, all the chromium ions are now in the ground level E. Therefore, the condition of population inversion is not achieved. So, due to this, the laser action stops or laser action ceases due to the non-achievedness of population inversion. So, the laser output goes down. Again, due to pumping these chromium ions, again accumulated at the upper laser level E2. So again, due to stimulated emission, the laser output goes on increasing. And again, at this point, the all chromium ions are now at the ground level. Therefore, the laser action again decreases and then again increases. So this is called spiking. So we can say that the main disadvantage of Ruby laser is that in case of Ruby laser, the output is not continuous. So in case of Ruby laser, the output is not continuous. And the second disadvantage of ruby laser is its low efficiency. The efficiency of ruby laser is very low. And the third disadvantage is that it requires high power for pumping. So these are some disadvantages of ruby laser. So this is all about ruby laser. Now in our syllabus there is another laser which is helium neon laser. So now we will discuss this another laser which is helium neon laser. So second laser which we are going to study is helium neon laser. Helium neon laser was world's second laser and it was discovered in 1961 by Professor Ali Jawad. It is also called the first gaseous state laser. Gaseous state laser. It is also named as first gaseous state laser. So now we will discuss it in brief. So according to every another laser, helium neon laser has also three components: active medium, pump and resonator. So in case of helium neon laser, what is active medium? So in case of helium neon laser, the active medium is helium and neon gases. The helium and neon gases are used as active medium in case of helium neon laser, and that is the reason why helium neon laser is named as gaseous state laser. So, and also out of helium and neon, the laser transitions are produced only due to the neon. So neon is also called the active center. Active center of helium neon laser. The helium and neon gases are kept in a cylindrical tube like this. This is a cylindrical tube in which helium and neon gases are kept. The ratio of the concentration of helium and neon gases are 10:1. And in this evacuated glass tube, there are two windows at its opposite ends, and these windows are kept at an angle which is kept at an Brester's angle for getting the polarized output. These windows are called Brester's windows. Brester's windows. So this is our active medium, helium and neon gases. And the helium gas is kept at a pressure of 0.1 torr and neon gas is kept at a pressure of 1 torr. Now The second component is pump. So in case of ruby laser, the pumping which we have used is the electric discharge pumping. There are two electrodes which are used for getting the pumping of helium and neon gas. The pumping is done by using the electric discharge between these two electrodes. These two electrodes have given a very high input, so that there occur an electric discharge between these two electrodes, and the helium and neon atoms gets in the excited state due to this electric discharge. So these are the electric discharge electrodes. Now, the third component of helium neon laser. The third component of helium neon laser is optical resonator, and in case of helium neon laser, we use the two mirrors outside this evacuated glass tube. So, for making the optical resonator, two mirrors are used. This is mirror M1 and this is mirror M2. The mirror M1 is 100% reflecting and the mirror M2 is nearly 99% reflecting and 1% transmitting. So these two mirrors form the optical resonator of the helium neon laser. So this is the basic diagram. So whenever the high output is given to these two electric discharge electrodes, then a high electric discharge is produced between these two electrodes, and due to this electric discharge, the helium and neon gases gets into the excited state, and whenever these neon atoms gets into their lowest state of decay to their lowest state, we get the laser transitions. So now we will discuss the energy level diagram of the helium neon laser. So the energy level diagram of helium neon laser is somewhat complicated, and it is as shown. That this is the ground level of helium gas, and it is represented by He1, and this is the ground level of neon gas, and that it is represented by Ne1. So first of all, due to the electric discharge, all the atoms of helium and the atoms of neon gets into the excited state. So due to electric discharge, the atoms of helium also gets into the excited state, say He2, and also some helium atoms gets to the further higher energy state, which is first He3. Similarly, the neon atoms also gets into the excited state. This one and this one due to electric discharge. That here this is the energy level 4 and this is energy level 6. So due to electric discharge, atoms of neon gets into these two excited states, Ne4 and Ne6. So in case of helium, the lifetime of these two energy levels, He2 and He3, is very large. Therefore, the atoms starts accumulated in these two upper levels, and they cannot decay radiatively from their higher state to ground state. So they just transfer their energy to the neon atoms whenever they strike with the neon atoms, and this is called resonance energy transfer. So whenever an excited helium atom gets collided with the neon atoms, then it transfers its energy to the neon atom, and this transfer of energy is called resonant energy transfer. Now the atoms in this level Ne6 and in this level Ne4 gets de-excited stimulatedly to two levels Ne5 and Ne3, like this. So we get stimulated emission from level Ne4 to level Ne3 and also from level Ne6 to level Ne5. But in these two stimulated emissions, we does not get the light. We get the infrared radiations whose wavelength is 3.39 micrometer, and it falls in the infrared. And also in this transition, the wavelength which we get is 1.15 micrometer. This also falls in the infrared region. Now, stimulated emission of laser light which we get is due to the transition of atoms from level Ne6 to level Ne3. So whenever there occurs a transition from level Ne6 to level Ne3, we get the stimulated emission of laser light. We get a light of wavelength 632.8 nanometer, and it is the red color wavelength. So in case of helium neon laser, we get the stimulated emission of radiation between these two levels Ne6 and Ne3, and this wavelength lies in the visible region. So we get a red colored light from the helium neon laser. Now the neon atoms which are accumulated in this level Ne3 spontaneously decay to the second level Ne2 and gives the orange light. And now the neon atoms which are in the excited level Ne2 strikes with the walls of the tube and comes in the ground state. So this process is repeated again and again, and we get the stimulated emission of radiation. So this is all about the helium neon laser. So the advantage of helium neon laser is that it has the continuous wave mode, means we get the continuous wave output from the helium neon laser, and its output is nearly in the range of milliwatts. So the helium neon laser has a wide number of applications. It is used for communication purposes. It is used as a carrier wave in case of optical fibers. It is also used in cutting, welding, etc. So this is all about today's lecture. If you have any problem, so then you can mail me at my mail given below. Thank you.